Hello. In the last video, we learned the combination rule, and its mathematical formulation looks very difficult, but actually, it's simple as this. Read the pattern, and then it's not that bad, though still it's bad still. Anyhow, I ask you, count the number of possible combinations when you choose 3 out of 5. So there are 5 reservations, and you know 3 of them are canceled. Then how many different combinations can you think of? The answer is 10 using the rule. So numerator starts from 5, denominator starts from 3, and 3 to 1 in the denominator. Then 3 numbers are multiplied. So you multiply 3 numbers starting from 5. 5, 4, 3. Multiply. Cancelled out, cancelled out. So it will be 10. That's not that bad. If in this case, it's simple enough to do the brute force method. Brute force method is to write down all possible cases. Simply write 5 numbers with zeros and ones, and you have to have 3 ones. How many different combinations can you do? These 10 different combinations. Cancel, 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 no, no. Cancel, cancel, no, cancel, no. Cancel, cancel, no, no, cancel. In this way, you can write 10 different ways. There is no other way. But always the problem here is it's confusing. If you forget one of them, if you miss one of them, in the end you will be wrong. So if you're confident, you can do it, and it of course it takes more time. So if you may do this way, but of course I recommend the general method, which can be applied to any case, and it can minimize your mistakes. So then now we are ready for the general binomial distribution probability formula. So in general, we have a binomial random variable y with probability n and p. N and p are the parameters for this random variable, and we are interested in probability that y equals to lowercase y. Then you remember there are 2 parts. This probability consists of 2 parts, first part and the second part. First part is the number of possible combinations uh, under n chooses y. So it's combination rule. N chooses y. This counts the number of possible outcomes in this event. And the second part is the probability of a single outcome. We learned this. So when there are n trials and the number of success equals to y. So probability of success multiplied y times. Probability of failure 1 minus p multiplied the other times. The remaining n minus y times. That's it. That's the final rule. Uh, it's simple, like it's just one line, but you have to. So actually, the main problem is coming from this, and when n is large, you cannot calculate this by your hand. So you have to use a calculator or Excel or a program, and especially also if y is large, say like multiplying zero point 0.1 several times is not easy to do without calculator. So it usually requires a calculator or a computer. So now let's come back to this problem. This is our goal. We want you to answer this question. There are 10 reservations, and probability of cancellation is 10% for all of the reservations, and all cancellations are statistically independent of each other. What is the probability that exactly 2 reservations are canceled out of 10? Now, uh, still the idea is the same. You have to calculate 2 things the number of possible outcomes and probability of a single outcome. Probability of a single outcome is easy. Let's like 10% happens 2 times and 90% happens the other 8 times. Okay, the second part is easier, but the first part is now a little bit more complicated because it is 10 chooses 2, 10 chooses 2, and then you cannot do this by hand. You cannot list all the things. It will be super difficult. So let's do this together. First, try it by yourself, and I will show you the answer. We know the answer, but still try. We know the answer is the last one, but confirm by yourself whether it is correct using a calculator or a program. Take a moment. I will count 3, 3, 2, 1. So first you have to find the parameters 10 and 0.1, which is obvious. And using the formula, we are looking for y equals to 2. So 2 cancellations out of 10. So 10 chooses 2 is the first part. And the second part is this. It's clear. Cancellation probability happens twice. 90% non-cancellation probability happens 8 times. So the first part, 10 chooses 2 becomes 10 times 9 in the numerator, 2 times 1 in the denominator. So it is 45. So without the rule, how can you count 45 like by writing all the possibilities? The brute force method does not work. Like it's very difficult. You have to write 10 numbers 45 times. So it's nearly impossible without calculator. And of course, this is also impossible without a calculator. How can you multiply 0.9 8 times? In the end, it will be 0.4305%. So in the end, when you multiply that, it will be 19.371. That's how we get the answer. And now you understand why the number is this much complicated. So it's not that intuitive, not that straightforward. And let me summarize intuitively why it's complicated. There are two blind spots in your mind when I first ask you that question. So when I first ask you, what is the probability that only 2 reservations are canceled? Then when I ask you this question, I did not mention 2 implicit assumptions. First, it implies when I say 2 reservations are canceled, you have to think about the other side, the other side of the sentence, which is this. When I'm only saying 2 reservations are canceled, but you have to think about this probability too. You have to think about the probability that the other reservations are not canceled. The other reservations are not canceled, which is this part. Often this part is ignored because I don't say that in sentence, right? You have to catch that implicit events, implicit outcomes when I say 2 cancellations, only cancellations. And also, this is another blind spot. It looks like one outcome. When I ask you just 2 reservations are canceled, it sounds like there is only one outcome. Then okay, think about 2 cancellations and 8 non-cancellations. Okay, then that's it, but actually not. There are different scenarios and you have to calculate probability for each of them. So, and it's usually forgotten in a usual, like without understanding the binomial distribution. So that's simple summary of what we have done, and keep this in mind. Binomial distribution is not easy. It looks easy, it looks simple enough, but actually it's quite counterintuitive in many cases. So, and it's also very complicated to calculate. So we are going to, but anyhow, we obtained the general probability rule. This is the general formula to use when you calculate a probability. So get used to this, do some practice by yourself, and I will continue in the next slide. Continue in the next video uh, based on this general probability formula. Thank you for watching this video. See you in the next video.